Have you ever wondered why virtualization and containers are such crucial components in the world of Linux? Well, let's dive right in. As the digital landscape continues to evolve, Linux systems are constantly adapting to accommodate these changes. This is where virtualization and containers come in. These technologies have become integral to maximizing system efficiency, enhancing isolation, and streamlining resource management. Think of virtualization as a way to get the most out of your system resources. It allows multiple operating systems to run simultaneously on a single machine, each with its own virtual hardware. On the other hand, containers are like lightweight versions of virtual machines. They package up an application with everything it needs to run, ensuring consistency across different environments. Both virtualization and containers contribute to the overall flexibility and functionality of Linux systems. They allow for better resource utilization, scalability, and isolation, making Linux even more powerful and versatile. So it's clear that virtualization and containers play a significant role in Linux, but what exactly are they? Let's dive into virtualization first. It's a technology that allows you to create multiple simulated environments from a single physical hardware system. So what does this really mean? Well, imagine having one computer, but on this computer you can run several other operating systems simultaneously. That, my friends, is the magic of virtualization. In the context of Linux, virtualization is a way of maximizing the use of your hardware resources. By using a piece of software called a hypervisor, Linux can create separate virtual machines, each acting as a distinct computer with its own operating system. This means you could have a Linux machine running a Windows operating system and a macOS operating system all at the same time on the same physical hardware. But why would you want to do this? There are several benefits to virtualization. First, it allows for improved resource utilization. Instead of having multiple physical systems, each running at a fraction of their capacity, you can have one system running multiple environments at near full capacity. Second, virtualization provides system isolation. If one virtual machine encounters an issue, it won't affect the others. Lastly, it's an excellent testing environment. You can easily spin up a virtual machine, test a new piece of software or configuration, and then just as easily discard it without affecting your main system. Virtualization, therefore, offers a practical way to maximize hardware usage while maintaining system segregation. Now, on to containers. Containers, on the other hand, are a lightweight alternative to full machine virtualization. Think of containers as individual self-contained units, each housing an application along with all its dependencies. They work in Linux by creating isolated user spaces, effectively carving out a portion of the system for each application to run in. The magic lies in the fact that while each container feels like a full-fledged Linux system to its resident application, they all share the host system's kernel. Now, why is this cool? Well, because containers are not burdened with the overhead of a full operating system. They're far more lightweight than virtual machines. This translates into quicker startup times, making them perfect for applications that need to scale rapidly. But that's not all. Containers also provide application isolation. This means that each application runs in its own safe space, insulated from the others. So if one application crashes or gets compromised, the others stay unaffected. It's like having separate rooms in a house. If something spills in one room, it doesn't mess up the rest of the house. Moreover, as each container has its own environment, you can run different versions of the same software without any conflict. This is a boon for developers testing their applications across different environments. So, while containers might seem similar to virtualization, they offer a more streamlined approach, especially for application deployment. In conclusion, virtualization and containers are two powerful tools in the Linux toolbox. Each offers unique advantages that can significantly enhance the performance, flexibility, and efficiency of your system. Virtualization stands as an effective way to maximize hardware usage. It allows multiple operating systems to run simultaneously on a single machine, each operating as though it's the only one present. This approach not only maximizes hardware usage, but also offers a high level of isolation, making it a safe and efficient solution for testing and development environments. On the other hand, containers take a different approach to achieve similar ends. By encapsulating an application and its dependencies into a single standalone unit, they streamline the process of deploying applications across different environments. This ensures consistency and eliminates the "it works on my machine" problem. Whether you're looking to maximize hardware usage with virtualization or streamline application deployment with containers, Linux offers the tools to make it happen.